Okay, this is ARO-280, page 101. Only section available for this class. Everybody on my list is in the room except Lance. So I'm assuming that everybody is supposed to be in here. Day number 1, course objectives and safety, which is actually covers chapter 1 and chapter 2. Chapter 1 is the course overview. Course goal: by the time we get done with this course, you should be able to better understand the 2D vision concepts, set up vision equipment software, set up of communication between robot and teaching computer, be able to perform a camera setup and camera calibration, be able to add vision commands into a teach-pendant program, troubleshoot vision equipment processes and programs. Objectives: students successfully completing this course will be able to, are you ready for it? Ready?
I don't know if I'm ready.
Identify the advantages of a FANUC ARO vision system. Identify how a camera may be mounted, and identify various ARO vision processes. Hardware. Identify hardware items for 2D ARO vision. Hint, it's camera. Software: install ARO vision software options. Connect teaching PC to the R30IB Plus controller. Navigate the IR vision menus. The software is already installed. We're not going to mess with that. Vision concepts: understand the basics related to machine vision. Gain a general understanding of how light affects the vision process. Identify outcomes of various lighting techniques. Prepare for vision mastering and then execute vision mastering. Understand the purpose of a calibration grid frame. Understand the purpose of the application frame. Understand the purpose of an offset frame. And then execute vision mastering. Do camera setup, view the vision device setup screen, understand coaxial camera information, understand GIG-E camera information. GIG-E is the Ethernet cameras. We don't have any GIG-E cameras, all of ours are coax. Create a camera file and calibrate the camera. Grid pattern calibration: first you need to understand what calibration is, then execute a grid pattern calibration, review the calibration points and results to check for irregularities. 2D single view vision process. We're going to learn the different types of 2D single view vision processes, understand how offset data is calculated, create a 2D single view vision process, and then test the 2D single view vision process. VRs and instructions. Going to understand the information contained in the vision register, what a VR is. If you guys understand PRs, then VRs are a piece of cake. Learn IR vision specific programming instructions and create an IR vision program. Actually, more than one. Model learning. Use model learning to optimize a trained model pattern. Compare the score and time to find out with and without model learning enabled as a means of recognizing the potential benefit. Got this bag full of terminal blocks here. These are perfect for model learning, because they're all pretty much the same, but there are very, very minor differences between them. You can also easily tell with the vision system if the two bars are in there or not. use them for pass-fail also. Blob locator tool. Successfully set up a vision process containing a blob locator tool, and then test the blob locator tool by running the vision process and teach pin program to collect a part. Blob locator tool is used whenever you do irregular shaped objects like those. They're all pretty much the same. There's enough variation where you need to be able to tell which ones are which. The way I did it last year was I had those and I think Ricola or different cost drive, and the robot could pick out which ones were which. 2D multi-view vision process allows you to create a 2D multi-view vision process, test process from teach pin program that commands robotic handling of a large workpiece. Basically, if the piece is too big to fit in the field of view of the camera, then you can use either more than one camera or you can just move the camera. Inspection vision process, teach a single view vision process, test single view inspection vision process. Test the inspection view vision process from teach pin programming. That's also perfect for doing an inspection on, because you can easily tell whether the metal bars are in it or not. If they are in there, it passes. If they're not, they fail. Right? Not much good without the metal bars in it. Chapter 2, safety. Ozarks Technical Community College, Ozarks Tech, is not and does not represent itself as an expert in safety systems or safety equipment. It is your responsibility to take all necessary steps to guarantee your safety. Don't lick the shiny bits. Staying safe while teaching or manually operating a robot is of paramount importance. Imperative that you observe and follow the rules. Don't wear watches, rings, neckties, scarves, or loose clothing that could get caught in moving machinery. Before teaching, visually inspect the robot work envelope to make sure that no potentially hazardous conditions exist. The area near the robot must be clean and free of oil, water, or debris. Immediately report unsafe conditions to your instructor. If you must enter the work envelope of the robot, be sure all safeguards are in place. Check the teach pendant for proper operation and place the robot in teach mode. Take the teach pendant with you, turn it on, and be prepared to release the dead man switch. Only one person or only the person with the teach pendant should be in the work envelope of the robot at any given time. Which means if I am operating the robot and I'm trying to see what's going on, get my position set, nobody else can be in there with their face in it trying to see what's going on either. Lab safety rules. In the training lab, do not work on any robot unless your instructor is present. Turn off all controllers when not in the lab. When entering the work cell, pay particular attention to the following. Only one person at a time may enter the work cell. Robot controller must be switched to teach mode. You must have enabled or turned on the teach pendant with you at all times. And do not place any body part between the robot and a fixed object. No one is permitted in the work cell when the robot is in auto mode. If it's running in auto, you can't be within its envelope. We have DCS set so that it can't reach outside the perimeter of the table. So as long as you're not hanging over the table, you should be all right. And that is the end of day number